Hey, it's me again. I'm happy you made it to video 2. Again, if you made it through the introduction, let's get right into graphing. Like I said, again, I gave you a little bit of a preview of what systems is going to be like and how solutions are going to look in systems, and that will help you with this first method of graphing. Again, like I said, I think you're really going to like this method in comparison to the other ones that I think are a bit more challenging. But again, work at your own pace, stop if you need to, and again, just come back to whatever you need to. So we're just going to go through a few questions here, and again, I kind of laid it out as much as I could. Like, first of all, if you realize, like, we're going to be solving, whoops, that was not supposed to happen. Okay, let's go right here. Again, we're going to be solving something that looks like this. Okay, so you see a bunch of variables there. It's not just x's anymore. It's not just like x plus 10 equals 15. Again, you move over the 10, and x would be 5. Again, it's not like our solving methods are going to be like this anymore. We're going to follow the same steps, but we have to do some tricks to get there. Okay, because we're going to be solving not only for x, but for y as well. Okay, so a solution occurs when the lines intersect. Again, I went over this in the beginning already in the introduction, but let's just review it right here. Okay, again, you're looking for a point where they're intersecting. That's where we have a solution. All right, and we know that coordinates consist of an x and a y value, and that's how we write coordinates. Again, you have your x first and your y follows. So for example, if your x is 10, you have a 10 here. If your y is -5, you have a -5 here. And again, your solution would be 10, -5. Just a basic reminder of how coordinate points work. Okay, I think you should be comfortable with that. Okay, so here is the system. Y equals -3x plus 6, again, that's this line graphed, and then y equals 2x minus 4, that's this line graphed. Okay, great. Again, I already provided the graph for you. Sometimes you'll have to make the graph on your own. So I'll practice one in this slide where you'll have to make a graph on your own as well. Okay, so I'm looking at the system again. I'm looking at these lines. They're crossing. I could see, and they're crossing right here at this point. Okay, before I answer the question, you think about it for a second. What are the coordinates of that point that it's crossing at? Okay, see if you can pause it for yourself and decide what are the coordinates of that point. I'll just pause for a second here. Okay, the coordinates of this point, again, you're moving over 2, so the x coordinate is 2, and we didn't move up or down on the y, so again, we're just here at 0. So your solution would be 2, 0. Again, I have an x, I have a y, that's exactly what I want. I see it's one solution, I'm done. Okay, so when the graph is provided for you, these are going to be pretty simple. Again, I'm not saying they're easy. I'm just saying it's going to be easier to do graphing than the other methods. So that's why we always start with this one. Okay, but let me scroll up here. Whoops, that's not what I wanted to do. Okay, let's scroll up here and let's work through these now. Okay, this is the next page, like in your note sheet. Okay. And I'll just pause for a second here. Again, you can pause your screen, try to work through them, okay? First, tell me if it's one solution, no solution, or infinitely many, based on the lines you see. And then again, if it's one solution, please actually tell me the coordinates of that point, okay? I will pause here, but again, you can also like pause for however long you need to try these out, and then you can check your answers with me. So I'll just stop for like 10 or 15 seconds. And this just resume whenever you're ready to go over them. Okay, so again, you pause for however long you need, but I'm just going to start going over the solution so you can check for yourself. All right, the first set of lines that I see here are going to be intersecting. Again, I see they're crossing. Think about it as an intersection. Again, like two streets intersect. It's where they're crossing. or if someone is throwing a ball to you, like if someone is throwing a basketball to you and someone jumps in front and they intercept it, again, very similar concept, okay? It's like a crossing. All right, I see they're intersecting right here, and the coordinates of that point are -1, -1. Okay, see there's only one solution. Okay, so that's all you have to tell me. Again, look at the type of line, how many solutions, and what is the solution. Okay, moving on to this one, again, same thing, I'm intersecting. Okay, these lines intersect. Again, give me the coordinate points because I see that there's one solution. So it's like over 3 and down 2, so it's at 3, -2. Okay, and this is the solution I'm looking for, the thing I just put a square around. Again, if it's one solution, I want you to actually tell me that coordinate point. Okay, let's move on to these lines down here. You should see it looks like a road. Again, they're going to be parallel. They're never going to cross or intersect anywhere. Again, I see multiple lines, so I know they're not overlapping. So this one's going to be a no solution. Okay, again, there's no solution. They're parallel. Obviously, if there's no solution, you don't tell me a coordinate point because there is not one. Okay, so all you have to write is no solution. All right, and for this last one here, again, if I go, like I know I'm going like fast through them because you can just pause the video whenever you want. Okay, I see a point right here, so I see there is going to be one solution because these intersect. All right, and that solution is over 4 down 3. So that point is at 4, -3. Okay, and that is the graphing method. Again, you're just looking at the types of lines and where they're intersecting. Okay, what you see me open right now, I just opened up a graph sheet. I gave everyone a graph paper, but again, you can just sketch it in your notebook if that's possible for you to do. Okay, let me see if I can grab something to write with. I don't know if it's gonna let me because it's a PDF. So give me 2 seconds. I'm going to just put this into a OneNote document. That way we can go through one question where you have to do it completely on your own. Okay? So here, I'm gonna give you a system of equations. All right, so let's do y equals 2x plus 4 and y equals 2x minus 2. All right, go ahead and pause the video for yourself and graph these two lines in your notebook. Again, we just practiced graphing like one line, but see if you can do both of them. Again, I know you can graph one line, but now all you're doing is graphing two lines on the same grid to get a system. Okay, so go ahead and do that. I'll just pause here again for a few minutes and I'll put up the graph so you can check. Sorry, that's the bell. Okay, again, I know that probably wasn't enough time for you to finish it, but please just pause it whenever for however long you need. So I'm going to graph this one first. Right here, I'll just put this green here because that's the color I'll graph it. Again, I start up 4, okay, and then I go up 2 into the right 1. So I'm going to go up 2 into the right 1 to get my next point each time. Okay, I'm going to connect those lines. Then I'm going to graph this one here. Again, my y-intercept is -2. I'm going to go up 2 into the right 1. Put the graph of my line there. And again, I see these are parallel, so there will be no solution. Okay, so this is the same thing we were just doing, except we had to actually do the graph on our own. So this is something else we practiced in class as well. Okay, so again, if you need more examples with graphing, let me know, but there were just 5 or 6 for you to look at, okay? I hope those helped out. I'm trying to stop the video and I don't know how.